Page 353, number 2. The question said we have a polynomial that is monic with fourth degree, and the roots are 4 and 2 plus or minus 3i with real coefficients, and the question is to list all the possible roots, all the possible polynomials that have this property. There are actually two answers. You can have f of x is equal to, well, let's first deal with these roots. We can have x minus 2 plus 3i. And then multiply that by x minus 2 minus 3i. Okay, that's quadratic, and so we need to have a triple root of 4 to compensate. So this is the first of the possibilities. The second possibility would be to have g of x equals, okay, so let me copy this down. Actually, let's copy just this part down. And what we're going to do to change it is make both of these things squared to have the exact same exponent. And so by doing so, the x to the minus 4 term only needs to be raised to the first power to once again get a monic first degree polynomial with a 1 in the leading coefficient, polynomial of fifth degree. So these are the two solutions that actually work. If you actually multiply these out, for this one it's x minus 4 cubed. And then this term is the irreducible quadratic x squared minus 4x plus 4 plus 9 for plus 13. And then the second polynomial, if factored over the real numbers, would be equal to pretty much the same thing, except we have a x squared minus 4x plus 13 squared, and the x minus 4 term is now raised to the first power. The most common mistakes in this problem were having different exponents on these two terms. We need to have matching exponents here so that when you multiply them together, the i's all cancel out and get something that has real coefficients. I'll let you check that if you make this a 3 and you make this one a 1, if you multiply it out, you get complex numbers. And so these are the only two polynomials with real coefficients that actually work. Okay, so that's page 353, number 2.